Okay, our emergent humanity. So I'm very pleased to be here. This is our fourth tutorial with Project Aria, and it's actually our fifth year of externalized Project Aria. And I think, as we say, and hopefully you get to come along to is it a party on Wednesday? It's really the community that is built everything that is worthwhile in Project Aria, built, of course, upon the tools. So hopefully you'll get to see lots of good stuff today on our new generation. But I want to give us a bigger picture, because you're going to get a lot of great technical talks from people, and I'm going to leave that to them. I want to point out that it's really rare in the history of humanity to have an experience of all of humanity seeing their entire species from a different perspective. And just recently I was doing a talk, and we used this Apollo 8 mission to sort of really get this point across. This was a photo of Earthrise that was taken on Christmas Eve from the folks who were on their way to the moon. And they turned around and took this snapshot. And it's kind of fascinating to think of what this really represents in that blue marble, all of humanity. And the perspective, of course, of seeing for the very first time the entire world encapsulated in, what is effectively a very low resolution photo relative to what we're used to today, really profoundly changed the way that people think about themselves on the planet. Because the point is, it's kind of whatever it is, the good, the bad, the potential, it's all inside of that blue marble, as it was. It was incredibly powerful. And it's amazing because here we are, 40 odd years later. Is that right? More than 40 years later, isn't it? My goodness, 70 years later, on the order of. And it's like we are in a position, what is it, Michael? It's like 65, 67. All right, we're going to scratch that from the video. 57 years later, we're still wondering about this photo and what it really means to us. But there's a couple of things that I want to say, which are, let's not forget that everything really still is mostly inside of this blue marble, and that we are yet to really understand it. And what I mean by that is exactly the emergence of humanity. How did it happen? Where's it going? And where's it going with our technologies? So let's begin. Frias Corinthi introduced us to this idea of the 6 degrees of separation, which means that even though there's 8 billion people on the planet today, you're just 6 steps away from interacting with anybody. That is to say that you know somebody who knows somebody, ... that knows, at the very least, Logan in the background here, if not Kevin Bacon. And the reason why that's important is because it means that you're really extremely connectable on this planet. And that was actually true even before the technologies that we have today, like the internet. Of course, the internet has brought us together in an even more obvious way. So even though it's a very big planet with lots of people, in principle, you're just a few degrees away from anybody's mind and what they might have to do to help you with anything that you're thinking about, and you the same for them. Now, on the other hand, your perspective is much more related to this thing called Dunbar's number, which is from Robin Dunbar in only the early 1990s. They did some analysis on the neocortex size of primates, and they were sort of correlating brain size and the capacity to have social networks. And what they found was very interesting, because it was effectively quite related to something that's very intuitive, which is that you have just a few close friends. You have a lot more acquaintances that you might interact with on a direct way, but not as much as day to day. And then you sort of have this growth of the number of people that you interact with, but not necessarily directly, and on, up to about 150 of people that you might really know their names about. And it's a dynamic network, so people will pop into your group of about 150 and they'll pop out again. And overall, that sort of defines your social reach. So, even though if you think about the blanket of these local networks and how they connect via the 6 degrees of freedom, your actual perspective interacting on the planet is kind of defined by Dunbar's number and your local, up to your acquaintances. Like I say, Facebook did a pretty good job of connecting the planet, and sort of by sort of the early 2010s had already got billions of people connected on social networks. And that, of course, has exploded since then. Now, the reason why I introduce all of this, it seems to have very little to do with perhaps computer vision. is because I think it's starting to become clear to a lot of us in the field that when we look at the sort of overlapping sciences defined by robotics and the new area of contextual AI, so this is the interaction between wearable devices like Project Aria glasses and Ray-Ban Meta devices, and the advent of AI, internet scale AI in particular, then what we really start to see is a reflection of really the bigger challenges of understanding humanity. So think about it like this. The data that is used to drive the great LLM revolution only exists because social networks and the World Wide Web exists. If it didn't exist, the data wouldn't exist to train those giant LLMs on. That's kind of fascinating because certainly the order of operation was social networks were built because people wanted to interact and communicate. And so you have YouTube and Instagram and all the other sorts of blogs on the wider World Wide Web. But ultimately, that reflection of humanity is now captured inside of LLMs. And it doesn't look like it's going to change anytime soon. Certainly we'll see today the use of data sets that are more like simulation data sets and very technical data sets. But when we talk about scale of experience, it's the human experience that's being captured in today's AI. Now, we also have robotics, which again is kind of a reflection, especially when you think about like the potential for humanoid robotics that directly interface the world that we've created for humans. The idea is that if you're going to create a robot, it might as well be sort of humanoid because then it can interoperate with all the things that have already been built for humanity. So when you take these together, then what you can say is that in some ways, AI is a way of studying human minds and societies interacting. And, robotics certainly is a way of getting at the capabilities of humans interacting. But if we really think about the science of the problem, how is it that humans get stuff done? It's really a discipline in itself, of course, has overlap with the great social sciences and social psychology and all other walks of human science. But I don't think we really take it that seriously within our sort of more mathematical sciences. And the reason for that, I believe, is because we haven't had the tools to study it. And in that light, then I'd like us to think really for the first time about Project Aria being the very first time that we can start to study humanity at the individual level and hopefully over time at greater scales, not just to furnish our contextual AI capabilities and future products and robotics capabilities for our data sets, but actually to truly understand what is going on in our human societies. How is it, in fact, that we go from local interactions on a day-to-day basis to global societies with economies and ultimately civilization as we know it? And it's all done through humans interacting with each other now, and of course, growingly with humans interacting with AI. Okay, so let's have a look at these kind of bigger pictures. First of all, I want to ask a simple question that is a bit leading because it has an answer. Do our lives have a shape? So I want us to start to think about the larger scale patterns in human lives. And we're kind of fortunate because Kurt Vonnegut had a whole theory around this that he developed for his master's thesis. He sort of said, look, a life has a beginning and it has an end. And in fact, stories have a beginning and they have an end. And throughout a particular story, you can think about following the protagonist, and they might have good fortune and they might have ill fortune. They might have an unfortunate situation, or they might get very rich and have a great amount of joy. And he pointed out that actually, if you follow up across all different parts of our civilization, there are shapes of stories, and there aren't that many. He sort of like indexed, several of them, and I want to take you through some of them. But the point is that they all map onto the shape that goes from the beginning of the story to the end of the story, from a person's life beginning to the end of their life, or some segment in the end, taking shapes that kind of just transcend the actual content of the story itself. So here's a good one. This one is called Man in a Hole. And the story is, a man is doing just fine. His fortunes are, somewhere in the middle. And then he falls into a hole. And then he manages to get back out of a hole. And that's the end of the story. And the important thing for this story is that actually, after he gets out of the hole, he's slightly better off. Maybe he's better off because he learned something. Maybe he's better off because, frankly speaking, once you've fallen into a hole, things look a lot better than they did. But the shape is mappable onto a lot of stories that you may know from your own childhood and across our different societies. Here's another really famous one. This one's called Boy Meets Girl, although it's not specific to love. This one basically says, there's a boy, he's neither lost nor found the greatest thing. He has the experience of finding something he loves. He loses it, and then he gets it back again. And this particular story, again, maps onto things that you might see in your own reflections. The sort of more depressing side of stories are where someone starts in a very bad position, and it just, no matter where the story goes, it just goes downhill. It doesn't seem to get any better. And perhaps the most famous story of all, they say, is Cinderella, that maps onto a lot of extremely famous stories, including creation stories and a lot of sort of like societal creation. And it basically says somebody's in a pretty bad position in their life. They happen to get something from potentially a magical source. In the case of Cinderella, if you know it, it's a fairy that gifts various things to Cinderella over time, and her fortunes increase until one day she ends up at the ball, at which point the clock strikes and unfortunately she loses it all. But if you remember in the story, she gets it back again as Prince Charming comes along with the slipper. Now, the interesting thing is that this particular story maps onto some pretty profound, bigger histories of civilization. And like, why should it matter, these shapes of these stories? And it's like, well, when authors are penning these narratives, these stories are reflections on broader things in society. They're not arbitrary. And it's worthwhile imagining, if you can imagine any other shapes of stories other than these ones. There are a couple more. And of course, in reality, they wiggle all around as the sort of like time goes on. Okay, so that's a big picture. And the question is, to what extent is reality a sort of a story? And how can we talk about it that way? Now, what about at the more granular level? What's in the daily life of a person? Well, this is a view that we've been talking about now for about 3 or 4 years. We've basically been saying, look, if you're going to have these devices, these wearable devices that can get closer to the action, different from satellites in space that really couldn't penetrate, what was really going on. They would map Earth, but they wouldn't really be able to see what you're doing. Then you can start to get at the level of granularity of literally every single moment through your day. But when we ask, what is it that you need to represent? It's kind of like, it just keeps going. Is it important to represent the event of me brushing my teeth? Is it important to represent every time that I sort of like have a movement of my hand interacting with the dog bowl? Like, where does it end? Every eye movement might be important to the story of my life, right? It's interesting to think about that. That's a question of representation, which is very important, of course, to the reason why we're here and look at the algorithms that are trying to represent our reality. So even the smallest moment, like a bit of exercise, might actually be profoundly impacted by something like my increase in heart rate that leads to a strange feeling, that leads to me doing something unusual. And if we don't capture the particular signals, the question is, have we lost the potential to represent a life? Is there no end to the granularity that we must represent reality? That's something to think about. At the other end of the spectrum, again, we've got day-in-a-life patterns that sort of like transcend the individual, but seem to produce macroscopic scale behavior. So this here is a day-in-a-life representation of Americans from the 2014 study that was then animated. I don't know if you can quite read the text down there. Let me see. It was based on the American Time Use Survey. So what's going on here is that 1,000 people are being represented at minute-level granularity as they transition throughout their day, minute by minute, and I've just sped up the simulation here. And what you're going to notice, of course, is something that I think, if you stop for a second and think about it, is that a lot of people are going through exactly the same patterns every day. There are some notable exceptions. Some of you may spot it if you've got a keen eye. But we started with, in fact, let me just start again now that you know what we're looking at. We start with the fact that most people are asleep at about 4:15 a.m. I got to tell you this morning, I wasn't asleep because of the jet lag from London, but that's an unusual situation. Most people are going to be asleep if they're in their own time zone. And as we set this simulation in motion, you'll see that it goes from sleeping to an interaction with personal care, from personal care to via traveling to work, from work to interacting with leisure. So people straight after work will travel often to leisure, and then they'll travel back home and do housework, some people, childcare, and other sorts of activities into the evening before finally again getting to sleep. So let's just watch this together as we see it happen. Eating and drinking, of course, everyone's got to do that at some point in the day. I'm not entirely sure what was in the miscellaneous category. These are the top categories, by the way, from the survey. So when you see up there volunteering, that's a significant part of the percentage of the people that were studied. Okay, we're getting into the evening now, a lot of leisure time, back into personal care as we then flow into sleep again. I see a lot of people in the pink work cluster at the bottom here going straight from work, straight to sleep. We might recognize that behavior in ourselves. Okay, so there's two levels of granularity, the fine grain and the very coarse grain. But none of this really talks about cause and effect. And yeah, if we're going to really understand the stories of our lives and how it is that the complex social interactions emerge from local effects, we kind of got to understand cause and effect. And so I could find no better example, actually, than one of my favorite episodes of Seinfeld. So hands up here who remembers the episode The Wink. Anybody? Just a few? Okay. Now, I haven't got the video, but I do hope you look this up on YouTube, because I can assure you it is funny if you look at the video. I'm going to keep it purely academic here for an analysis purpose. Now, what happens here is that Jerry is with his best friends in the diner that they often will be found in every single day. And he, for whatever reason of his diet that day, is eating a grapefruit next to Elaine. Elaine's like, "So it's a grapefruit today, Jerry." He's digging in. Anyone who's tried a grapefruit will know that the local interaction with that physical apparatus can be tricky if you're not an expert of cutting a grapefruit up, right? Imagine how we're going to capture that onto our personal timelines with Project Aria. Whoops, it seems as though some of the juice has squirted his best friend George in the eye. Now, one can only imagine the comedy that is going to ensue for an entire episode of Seinfeld on the basis of simply the setup of some grapefruit juice which is squeezed into his eye. Now, later that day, George Costanza is at work. He is working at the Yankee Stadium here, and unfortunately, he has an irritated eye. Who knows this story so far? Who can predict it? It's difficult, right? If you don't know it. Now, of course, his boss comes in and starts to ask George about some information about one of his colleagues who, from his point of view, is not quite doing a good job. And so George, who starts to, of course, try and interact with his manager in a very professional way, tries to give a straight answer, at which point his eye irritation makes him wink. And the wink causes his manager to say, "Oh, I see what you're saying, George. You're trying to be kind to your colleague, but actually he's obviously a bad guy." And I won't spoil the rest of the story, you should go and watch it. But this goes on several times because of this wink. This wink that is in fact not because he wants to wink, but because of just some grapefruit juice that's in his eye. Now, how are we going to tell the difference between the wink, because of some grapefruit juice that's in your eye, that actually does have an effect, for example, on your manager, taking some input in, thinking that you're really saying something else, then, for example, when you really are trying to say something else to somebody. Now, think about where else this goes on. If you have children, you'll know that there's a difference between a look and the look. The look that says, "Stop doing what you're doing, otherwise I'm going to have to come over there and intervene with your behavior and get you back on track." Parents use it all the time, I'm sure. In fact, let me take a poll. Who's a parent here who knows how to use the look? Of course, every parent knows how to use the look. These are the kind of subtle behaviors that we need to be able to capture. Think about it. The children who you're interacting with when you use the look versus just a gaze in the general direction, they are already able to understand the difference between the two things. So I ask you this, are our AI systems on our embodied glasses ready for that level of understanding? Okay, that's cause and effect. Now, if we could start to capture this level of granularity, this is good cause and effect. When something happens out there, we all look over there. adding some levity to my presentation, the cause and effect graph. So this is something that I've been playing with now for a few years, and I still really don't know how to talk about it cogently, represent it graphically. I'm really struggling to imagine how, even if we had all that data for the scientific enterprise of understanding how humans do what they do, how we would really go about studying it, But let's look at it this way. If I was to say that there was Ming-Fei, Richard, Jacob, and Ashley all in a room, we could take some primitives, and we might imagine that we ourselves impact ourselves via thinking, whatever it is we're thinking. But we can also have these actions that cause other people possibly to have other actions. And so in that sense, then you can capture the impact of how an action causes another action. And in that sense, there is a cause and effect graph to be built at some point. So Ashley speaks to Jacob, who moves and speaks to me, who writes something to Ming-Fei, who speaks to Jacob, who then writes an email to absolutely everybody in the department. And so it goes that we could capture such a phenomena. Now, the question is, are there patterns in this cause and effect graph? And I want you to imagine in your mind's eye that you really blow this up to the scale of entire societies. Are there entire patterns that can be replicated and predicted? Are there things that actually represent something that when we look at the cause and effect graph, we say that is an argument happening over email between two people, with a couple more people on the email chain not interacting, but that's what it looks like. And I think the answer is yes. I think that this is the shape of human interaction that we can start to think about capturing at scale and start to detect or identify things that do map onto everyday language. But of course, to do that, we're going to have to be able to get those primitives. And I put it to you as well that those primitives that I put up there, which are just examples, like I said at the beginning, how fine-grained do those primitives need to be? Does the look need to be up there, etc.? Tone of voice, the raised heart rate that somebody may be able to detect, and so on. These are all the questions that we need to answer in this new science. Okay. At a completely different scale, we can start to look at this phenomena at a sort of more statistical level, at a level that is more akin to physics. And I did build a little simulator because I wanted to demonstrate a simple phenomena. Let's see how we're doing for time, James. Pretty good? 5 minutes. Yeah, we could do it. Should we try and do it? All right, let's try and do it. So I think I've got to, let's see here. I need to just extend, which is good. Network structures. So let's see. I built a couple of simulators. I'll just show one. It's time for one. Unfortunately, we weren't able to get my my screen to mirror, so I have to literally turn my laptop around so that I can see the screen over here. But I think that'll be all right. Okay, you can still all hear me, okay? Okay, so what we have here, in fact, I'm just going to turn a few things off to start with, is a very simple simulator. And I want to think of a blue dot here as being an individual going about their business in the world. You can see that I've got a couple of types of movement process. One's a random walk and one's a levy flight. If I just stick some sort of trails on, you can see what their movement looks like. This is like undirected random motion, right? Who here knows what a levy flight is? Anybody? No, okay. Well, I'll show you pictorially. A levy flight looks like this. So what you'll notice now is that there are big jumps followed by small little movements. A levy flight is a process that models, for example, animal foraging. So I might, for example, be looking for something, I can't find it here, I'll move all the way over there and have a look over there. It's also a pretty good model for things like isocards, so eye movements can be statistically modeled with levy flights, and so on. But I will keep it on a random walk because it keeps the conversation simpler. Okay, so there's a phenomena here where what I want to think about is a little bit abstract, but I think we can go there. I'm now going to show a radius around each one of these people, and I'm going to draw a black line if they are within that radius. Nice and simple, right? So of course this is just like a nearest neighbor based on a radius threshold. And as I increase this radius, when the graph turns red, it means that it is percolating. That is to say that there is a path from one node to any other node in the graph via effectively those n degrees of freedom that we talked about right at the beginning of this talk. Now, this has a particular sort of phenomena, which is to say that the graph becomes this way, has a large component that includes all of the nodes, and it happens within a threshold that is sort of very nonlinear. So there's a large region where this graph will not connect because there are multiple connected components, and then for a given radius, there's a point at which inevitably every single node will be connected via some degrees of separation. Okay, so that's all good. Now, the question is, what actually is a node representing? Is a node representing my location in space? Is it representing my belief about something in reality? Something, that perhaps is to be inferred? And is the distance, of course, not just space, but our distance in belief space? And the idea of when a graph is percolating in this way or forming a single large connected component, we can think about the fact that information can flow through such a network, and otherwise it can't. Now, this is interesting when we start to add in some behavior. So here I'll add some agency in, and I'll simply cause the nodes to start to flow in that direction. I'll turn the radius off. Now, the interesting thing about this phenomena is it sort of says, if we're all going in generally the same direction, in fact, we can have a much smaller overall radius with respect to our belief of a system. So let's have a look when we reset. You'll see that when I reset here, I randomize the nodes again, and it does not percolate. Well, it percolates, but very, very rarely. You see, it's not turning red. Now, when I turn on and let the agency go, you'll see that if we just give it a second, at some point then everybody's kind of going in the same direction. You can think of it as being squeezed into an agreement of thought space, and eventually then the network will start to percolate. There it is. So you can see there's two big components there. If we leave this going for long enough, what we'll end up with is the fact that as people have agency that align, in this case, in a sort of a conceptual thought space, then in fact the information can flow. And this is the value of having things like shared common goals. It's very interesting. Okay, so there's one phenomena I want you to keep in mind as we go through just the last bits of this presentation. Okay, so here's a simple question for everybody. If we are represented as one of those nodes, in space and time or in abstract thought space, how, without an external godlike figure, do we end up defining the actual systems by which any kind of agreement occur in the first place? So how for anything that says, this is where we're going to end up today, we know the way this works in practice today is because there are hierarchies of humans who are put in positions that say, organize each other. And we agree to that organization by those people, and so it goes, all the way from our socialization as children through the schooling systems into our adulthood. But if we're talking about here the science of the emergence of humanity, I ask you, how did that get started? How did we start to form clusters that in the end allow us to have systems of agreement? And so I'll leave us with just one question, which is, if we represent our networks of people and the edges representing something like beliefs, and these circles represent the fact that I can continue to essentially propagate my own beliefs, and then I influence other people via these directed edges, what kind of algorithms allow for us to share information without it being top-down defined? And this class of algorithm, in general distributed computation algorithms, has an incredible place, I think, in this new science, because effectively processes like diffusion, or otherwise what are called gossip algorithms, become incredibly powerful. So I'll give you a very quick example. Imagine that everybody here was to come up with a number in their head and not tell anybody about it. And you can only talk to your neighbor, to your left. And if you're on the other side, you can talk somewhere else. So you can form a whole chain here, right? How could everybody end up with an average of all of the values in this room? What is the algorithm that will allow that to happen without a single person being given all the information and then summing it up and dividing by the number of nodes or the number of people? What if you don't even know the number of people? Are there algorithms that can do that? Does anyone know? So how do you get the emergence of a global average that everyone can agree on, given the value that every individual has? Does anyone know this class of algorithm? No? So this is a very interesting class, and it's sort of at the heart of how it is that local interactions can lead to global, convergent, agreed-upon phenomena. And I guess I'm making some big conceptual leaps here, so go with me. But the question is, it's not just a number that's in your mind, they're your conceptual beliefs. They're what you know and what other people know. And you have to be close enough in thought space to be able to communicate with that person. But at the end of the day, that is a form of diffusion that's going on across people. Now, I don't have time to show you this particular demo live, but I just pre-plotted it here. The answer to the algorithm, which is how do you come up with a global agreed upon average that everyone has while only doing local interaction, is you do nothing more than you take the value that you have in your mind and you pass it on to your neighbors, divided by the number of neighbors. And they do the same. And when you receive their numbers, you take the thing that's in your head, divide it by 2, add the average of their values, and you just keep doing that. And you can imagine if you're used to diffusion processes in more continuous spaces, how that actually diffuses information completely globally after a number of iterations. In fact, that particular graph I showed right at the start, just after around 6 or 7 iterations, will achieve actually very high precision on a global average, with no actual hierarchical definition of a leader, for example, that does the summing. It's very interesting. Okay, so this was a bit of a different talk for Arya, wasn't it? Yeah, that's good. We're interested in all 3 of these things, and I think the one that's just getting going is the one right at the top. It's the one where the biggest questions for those of us in the sciences will start to look now that we start to have the tools to do it. Now that we have Project Arya, especially Gen 2, we're in a position where the kinds of sensors that get at where you're looking, what you're interacting with, where you are in space, what you're saying, what other people are saying to you, they can start to furnish those primitives that for the cause and effect graph over time can start to represent our lives and our interactions, the web of interaction across time, which we can then start to do science on. And of course, it will be valuable for robotics and it will be valuable for contextual AI because effectively that is the great new source of information that will guide us into how it is that humans do all of the complex things that we do. So if we study humans, we will get great results, of course, for our synthetic counterparts. But I put it to you that it's an extremely exciting time to get actually back into what is going on with humans now that we have these new tools. Now, today, you're going to see not just Simon showing, as he always does, that he only looks in a tiny region. So everyone probably has heard me say this at least 4 times now for the 4th tutorial. We now have the mechanisms with Arya to be able to know where you're looking and hence know, for example, what you may be reading. Some great work by Hyojin and team on reading in the wild. We have the kind of sensors that allow us to start to decode entire body poses so that what we're talking about here is not just a head pose in space, but an entire body configuration. So that, for example, it's not just the wink, it may be the point, it may be the wave, it may be all of these things that lead to the complex social dynamics when spun out over short to long ranges of time. And we have not just the individual self, but also the interaction of self with world, changing the state of the world on. I think it's one of the most profound things to think about, that all of the complexity that you see in the modern world in particular is a function of humans moving the world forward, often one brick at a time. Entire cities get built that way. Entire countries over millennia have been built that way. All of the complexity of the room that you're in, not just the local configuration right now, but literally every structure was built by hand. Now, we're obviously entering an era where that may not be true. Automation by robots may change a lot of that. But luckily, all that robotic stuff, just like the internet, is all captured digitally. So we can understand it very clearly. Whereas the stuff that we do in this analog world needs this new set of tools to capture. I'm just going to leave you with this point as well. With the new generation of Project Aria, we're in a position to have very highly time-aligned as well as space-aligned devices. Now, some really good talks on SLAM, VIO, localization happening at this ICCV. I think Jacob did a talk yesterday. We're getting to a point where you really can rely on the space-time frame of the device. And that leads to the potential of thinking about how when multiple devices are in the same environment, they can be put together in the same frame of reference as a new distributed sensor. And that itself provides a new foundational source of data for looking at the world, not just through a single image, but through a full sort of like encapsulation of that space, separated by whoever the wearers are. Okay, beyond that, of course, we think about egocentric, because this is the egocentric tutorial, but it's hopefully clear to everybody that if a single person wears a single device, the potential of that device to garner information of the exocentric world is just as profound. So being able to capture the behavior and understand what's going on of others around us becomes possible, as well as the wearer themselves. Now, with that, I don't know if I'm getting a look from James. No, it's a wink. That's pretty good. Thank you, everybody. Have a great rest of the tutorial, and I hope to see you around the conference. Thank you.